In this episode of Finno-Ugric Machining, we are going to make a brake. This is a brake for a boom that is attached to a missile which is driven in the forest to collect dead tree carcasses. And this is the material we have today to work with. It's 30 millimeters thick, maybe 20 millimeters in diameter, mild steel puck. As you could see, the center is still there. That's actually the first thing we need to work with. We need to get that center out. And after that, we can start turning the center hole, etc. But first, I will show you what this is all about. Here is the device which is then used to drag those tree carcasses out of the forest. It has a boom here attached to it, and then you can adjust the angle by these three holes, so it pivots from that hole, and then you have three here to adjust the angle of the boom. And then this is there is a bearing down there, which you can hear is already shot. And of course, it shouldn't be rotating freely like this. Originally, this Chinese piece of iron had a set screw here. I will now bring you a little bit nearer because the details are really interesting here. Okay, a little bit better to see the details. Okay, there is an M12 thread there, and there was a bolt which was supposed to lock this in place, so you couldn't rotate it. Well, it worked for its time, but the construction is like this. And now that I have opened it, this bolt went into these little slots here. It's actually a gear, but this one, as you can see, it's already shot. So, and if you think about that, you have a 1 meter long boom there, which you try to lock in place, and when you it's supposed to be rigid, and if this is the only thing that you lock it with, so everybody can tell that dragging from the end of that boom will actually do this for that. And of course the bolt is also gone. So are the threads here. We can do better than that. We forget about that thing inside there. Block this hole, or maybe my friend whose this is will block the hole. What I'm intending to do today is to have here a round piece of material which is bolted to the base, at least at one point, and then you can squeeze that ring around this. This is actually quite exactly 10 centimeters, so 100 millimeters, and it's sufficiently round in order to have that kind of setup where when you squeeze the ring, it will freeze this solid on place, and you don't need a lot of hardware to do that. But we need a quite large ring which is somewhat flexible, so that it's slit open in one end so that you can squeeze it. And then then you just squeeze it and it will lock this in place. And now, if you think about the diameter there inside was something like this, and this is many times more. So we have weaker forces now in play. Well, okay, as you can see, this is the book we are dealing with, and there is a web. We need to get this center away from there, and the cutting process, it was a torch which was driven by a CNC machine, and it didn't succeed in this one because there was some it stopped cutting here. I don't know why, but it did. And I said I can get rid of that. I should have known better by then. So now what I need to do is to drill a hole here. First a small hole, and then a large enough hole. Not large enough to get entirely through, or maybe, I don't know, let's see. But anyway, a hole, and then it's a lot easier to get rid of this piece. Well, now I'm going to drill a 5.5 millimeter hole into there. This should be quite near the desired place, yeah. And yeah, it's just, let's see about the speed. Yeah, it's okay. Not too much. Oh, okay. This tries to trap my drill. This is really white steel, so this shouldn't we shouldn't have too much problems doing this. Okay, it's through. Oh, wow. Yeah, first hole there, and now I need to change a bigger drill here. Wow, this is not very... Well, and it's smoking. Yeah. Okay. Have to stop the drill. Yeah, it's true. It cracked. But it's true. Oh yeah. Well, you don't need to grab your power tools each time you need to cut metal. In this case, the hacksaw would be nice, but unfortunately we don't have the room here. So I will be using the hacksaw blade alone with glass. Well, let's see if we can hammer it away. Yeah. There you are. Okay, there you are. Here is now my wonderful four-jaw chuck. Okay, so I have preset these jaws so that the workpiece should fit in there quite loosely. Actually, here is the workpiece, and yeah, okay, well, let's put it there so that it's well, not securely, but so that it is there. This rim is tapered so that now the back side here is larger than the front side. So that's the reason why I have it that way. And what I'm going to do now, well, I'm going to support it while dialing it in with my tailstock. So I have this wonderful piece of, well, material, one should say, which I can use to, like this, to use my tailstock to push it against the jaw so it doesn't drop from there. And since this is so uneven, I will have copper pieces there in between the jaws and the workpiece. These will absorb the unevenness of the material, and well, generally this gives a better grip for the workpiece. Is this too wide? No. Okay. Well, yeah. So I place the piece of copper between each jaw here, under, like that. So I have a collection of these there on top of my lathe. Yeah, this is the last one. Okay, now I tighten them slightly. And then look whether we, yes. This is, it's there. It's a little bit uneven, but oh, wow. Oh. And I really tighten this well. I don't want this workpiece to drop off from the jaws. It's there. I will now touch. Okay. Let's put it back. Yeah. Okay. Then I reset my dial here. And how much do we want to take out from this? Well, maybe 0.25 millimeters. So, here we go. Oh yeah. Wow. Well, the surface is not perfect, but it's good enough for us. This is actually very usable surface. At the moment, this hole is 86.00 millimeters. Yeah, it is. And well, we still have 14 millimeters to go, about. So let's go. I use a little bit cutting point there. Well, the only culprit here is that it is actually smoking a little bit, and that's not good. I need to ventilate this room every now and then. Let's try this out without cutting point. This smoke is really bad here. And it still has some on the surface here. Okay. Well, no difference yet. Well, I have 12 more millimeters to go. So I will come back when we are nearer the final size. Okay. Well, this hole is now 98.99 millimeters in diameter. Yeah, I measured it 3 times and I got the same answer every time. So what we need to do is to peel off something from it. And now the target dimension is 10.07. So we need to take away 1.07 maybe. So let's take that and call it a day. And now the last pass I made was 1 millimeter cut, so this will be quite identical to that one. So that's always good news. The cuts, the final cut should be identical to the previous cut at least. So a little bit of juice there, because we had a juice in the previous cut as well. Like that. And then we go. This is now the final cut. Yeah, okay. 1.07 millimeters. So the result should be 10.06. Let's see how it goes, whether it is or not. And yeah, this has started to build birds' nests, but that's not a problem, that's okay. Wow. Well, that should be our cut now. Let's see. I'll measure it and then we can tell. Well, and the surface finish became good. It's not excellent because of the quite fast feed. You can hear there is some crunchiness to it. But this is also a good thing. If I need to adjust it, so emery paper takes on very fast from that kind of a surface. It goes fast. And now let's see. It's clean. And let's see now. This is the first measurement. So our goal was 10.06. Man. Let's see. What do you see? In my books, this is 10.06. I want to make this really smooth. As smooth as this is, at least. Change the feed direction, I believe. Yep. There you are. Here now. That's it. And this is crazy smooth. Really it is. There is absolutely no, you can feel nothing on this surface. Okay, that's a way to make a really nice surface on hot rolled mild steel. So now I'm facing the other side of this, this thing. And now we are actually going to start this operation. One last thing to do is to turn this outer rim straight. I also have supported now this workpiece here in the middle with tailstock. It's pushing it, and this is a rather tedious operation. It will take forever. this is a thing where this whole thing will be attached to. And now the bolt pattern should be the same in the ring I just made. So, well, how to measure this? Well, it's actually quite easy. You first, how I do it, there are probably many methods to do this, but I take the dimension from the outsides of the holes like this. Yeah, and then make a note of that, and then I measure the inside of the same holes like this. Okay, and make a note of that. And repeat this same for all the 4 holes, and then you get a list like this. Well, here are the measurements I made. As it appears, first of all, the whole diameter is 13 millimeters, probably, yeah. And then I make an average out of these, so I get the actual distance of the centers of these holes. And it looks like we are at 99 millimeters. Sounds a little bit strange, but I would say it should be 100 millimeters. But yeah, it's 99. Inside 3/10. Yeah, okay. So I make it 99 millimeters. So here we go. Well, these serve just as a start point for. I will be doing those holes in the drill press, not here. Drilling with this machine is really tedious. So now, so now, drilling those holes. I will continue with this 6mm drill first, all the way through. And now, since we have the same drill here, it's very easy task to locate this hole. And let's see about the speed. Okay, that'll do. Well, I could use a little bit more speed here. Yeah, now it goes better. We are through. Okay. So now it's just to change the drill. So I need to change the speed. Let's see about that. Well, it's a little bit slow. That's about right. Okay, let's go. Let's see how this does. Well, it makes a horrific noise. I can tell this drill is not sharp. Nothing but sharp. Okay. When we got through the first surprise, then it... Okay, we are through, I believe. Yep. Yeah. So now I just repeat this process for the 3 remaining holes, and there you are. Yeah. Okay, the 4 holes are now drilled, and I made a small chamfer on them. Okay, now this is attached obviously to my milling machine. And one thing that you should notice here, that these are like parallels, and they are flimsy as such. So you shouldn't, as you can see, I have 2 here, one here and another there behind. Hopefully you can see it. Yes, you can. Well, now you can see it. That one. They are not parallel. This one is tilted this way. This gives it support both ways, this way and also this way, when you have it tilted like that. If it would be parallel with this one, there under, then this X direction support would be minimal, and that's not a good thing. Well, what I'm going to do, I'm going to mill this flat here and also mill away corners from here. So let's see. I try to touch first here. You have to wipe it so that that's the first flat done. Now I'm going to take that corner away, and I'm running this like 500 revolutions per minute, like that. Okay, I will keep on doing this until this thing is away. We have the drill now so that it is 12 millimeters from this side and 12 millimeters from that side there in the middle. And this is, since this is 24 millimeters thick, it's halfway. And again, this is a split point drill, so it should not wander. Yeah, it looks like to be the correct place, very good. It's not coming. I see the tip. There you are. Oh wow. Yeah. That was near to not to succeed. Well, it's only about 5 millimeters here in the chuck, and yeah. Okay, now this is a 5 millimeter drill. There will be a M10 nut at this end, and then when you screw in here an M6 screw, it will prevent that nut from spinning, and yeah. So, well. This is just, well, not very deep hole at all. Well, and we can use some speed here. Yeah, there is one problem with this kind of drilling. There is absolutely no feel on the feed, so you cannot tell whether the drill is grabbing or is crunchy or anything. It all feels the same. So that's a bad thing. Other than that, it's okay. So now, it's just tapping. Well, here is, well, it's going to be M12 thread, about half the way. And there is one problem though here. It's the tapping size of this M12 should be 10.4 10.4 millimeters. I don't have a drill like that. I have 10.5, but that's already like really loose. The minor diameter of M12 thread is a little bit under 10 millimeters, so this should go with this 10 millimeter hole. It shouldn't make too much trouble here, but you never know. We shall see really soon how this behaves. Well, not bad yet. Yeah, it's a little bit bad. You have to be careful with this one, really. Okay. Well, it's okay in a way. But it's still really tight. Oh man. And this is a very sharp tap. Well, yeah, okay. So now I know you have to make, I need to get a 10.4 millimeter drill. 10 millimeters is too tight. Well, now I'm going to drill a 17 millimeter hole into there. This is going to create a flexure for this. Well, it could be a little bit nearer like that. Yeah, okay. And yeah, I start with the 7 millimeter drill. Why 7? Well, no reason. It's just the one I happened to grab. So here we go. 7 millimeters. Could be faster, yeah, I know. Okay, it could be faster. So, yeah. Well, why not? There you go. Yeah. That's it. Then slow it down already, like that. About that, yeah, okay. Let's say that this is a good speed for this drill. Wow. I try to be careful with the last. Yeah, there you are. There you have the hole. Wow. Yo. So now slitting this open here, and well, this is just, well, cut it through, and I'm doing this in 3 millimeter passes. Well, normally you would actually cut the whole thing in one go. That's the preferred way of doing this. But well, I'm a little bit careful here. I don't want to do this, especially because this is not a not shattered, staggered. Yeah, staggered cutter. This is not one. This is one that has the teeth straight, and this is also so that these cutters are not flat. Cutters are not flat. They are wider at the rim and narrower at the center, so that they have some clearance. It's a very small difference, but there is a difference. Okay, and as you can see, I already made one test cut here, and I'm running this about 90 revolutions per minute, so 3 revolutions per second, and well, feeding by hand. This is my milling machine doesn't have a feed to that direction. And I'm adding the cutting oil directly to this plate. And then we go. Oh, we don't go yet. We need to have advance next 3 millimeters. So 1.5, 3. And then we. And this makes a horrific sound first. And now I do this multiple times, maybe 5 or 6 times, and then we are through. I'll come back when we are almost through. Now it's at here. Oh! Wow! Okay, up is quite good. Yeah. It didn't go, I mean. That's... it just slipped. And if it did... Yeah. No trouble at all. That's good. Wow. Haha. Oh. I'm feeling really careful. There you are, and now I pull it up like this. I don't make the mistake I made earlier. Pulling it back this way would Yeah, it's true. Well, is it? Is it not? Yeah, it is. Good. It's true. So, next. Well, let's see what's next. It will be the bolt. Okay, this is now becoming the bolt. Well, actually, it's there is part which is M10 at the end, and then we have some 10 millimeter rod, and then we have M12 thread, and then it continues there, and there will be a handle at the end. So, well, let's face it first. Didn't clean. Well, now it did. And next we drill a center hole, a center into this one. Well, yeah. Oh, there you are. Oh, no. Let it be like that. There is our center now. Let's take the first 1 millimeter cut and see how it looks like. Let's feel it. Wow, it's wow. Could this benefit from cutting oil? Maybe. Let's taste. It smokes. It definitely benefits from cutting oil. I can see it right away. Surface is much better, looks to be much better, but it smokes. Well, yeah, it had an impact on the surface pins. A very good impact actually. So we are at 18 at the moment, so now it should be 17. And it's really like cutting oil. It's hot. Now it should be quite exactly 17. Well, yeah, 100's over this time. 100's over there, and well, exactly here. Well, I don't know whether you see this. Yeah, it's very nice. So now I'm on the correct ballpark here. So it's 17, and now I will turn down these to 12 millimeters, and then I turn the end here to 10 millimeters, and I'll come back when I'm ready with those. Okay, well, first I will cut a M10 thread here. What was that? Much better. Well, okay, that's ready. Well, that's now the M12 die, and most conveniently I don't have the proper tool to hold it, so and you are free to laugh here. This is like really okay, this is now eyeballed, really eyeballed into place, and well, I'm going to drill a 9.9 millimeter hole through it, and yeah, a little bit more speed here. Yeah, this drill is 9.9 millimeters. Let's see if it wonders. It shouldn't, actually. I'm starting extremely carefully now here. See? No dent yet. This is, of course, this is the wrong way to do this. Please don't do it this way. Let me do the mistake here. Well, now I can see it there under. Okay. Then a 10 millimeter reamer. There you go. Now I have to be careful so I don't ream my table. Well, that's ready. Oh, I have a nice little workpiece. Yeah. that's about the break. I think that went quite well. It's you can tighten it by hand and it really, well, it grips. Better than the original design, which is, well, not very good. This one, it really works. The only thing about that is that you need to protect it against rusting. Just some Rust-Oleum on top of it and there you go. It's nothing more than that. In the next episode we are going to, we are maybe doing the crafting press, or we are going to cut teeth for this flywheel. Depending whether I get the Module 2 cutters. They are on the way from Ukraine and they seem to be somewhere. I don't know where they are, but they are somewhere. So now, but that will be in the next episode of Finno Brick Machining, yeah. So, till then, bye!